Welcome to the video for the lesson 3-3 in the 050 class. Um, you should have done the prep skills. Hopefully you did that. If not, go ahead and check the prep skills. We're going to be working with equations and expressions again. So as you notice, combining like terms is going to be important. Title of the lesson is All Things Being Equal. We're actually starting to talk more. The last lesson we set up equations, we established equations. Um, Now we're talking about what's typically called solving equations. So we go on to our classwork. Um, so first of all, in the classwork, they kind of have an introduction. Consider the following four statements. We know that New York City is not the capital of Guatemala. Um, Over 1 million distinct species of animals have been cataloged and named. Um, that's kind of an obscure thing, but the it's actually true, which I'll discuss later. Um, 8 equals 5 is not a true statement, and that's kind of what they talk about there in the paragraph below. Whereas 13 minus 10 does in fact equal 3. So we know that's a true statement. That's kind of what we're looking at now. Um, is, we can write an equation that says 8 equals 5, but it's not a true equation. It's not a true statement. That's what we want to look at in this lesson. So key ideas you notice, an equation is simply a statement that two quantities are equal. It can either be true or false. Um, so if you want to go ahead and take a look at um, question 1. Pause the video, come back when you're finished with question 1, and we can discuss it. If I can give myself some room here to answer the question. Question 1, the statement below contains a variable quantity. Is it always true or always false? So explain. So we look at the statement. The number of hours you'll spend on homework this week is 14. That's a statement that can be true, or it can be false. It's not always true. It's not always false. So in answer to the question, no, it's not always true. It's not always false. It may be true. It may not. Go on to question 2. Actually, I think we've got some things we want to discuss first. So before we go on to question 2, an equation written to represent a statement like this is called a conditional equation. Might be true, might not. If we use the letter H to represent the number of hours you spend on homework, we can write our equation as H equals 14. In this case, it should be pretty clear that if you have the value of H is 14, the equation is true, otherwise it's false. 14 is the only number you can plug in for H, which makes the equation true. And that's going to be what we're looking for a lot in today's lesson. So key definitions. A number that makes an equation a true statement is called a solution. So if we have an equation with a variable and we find that we can plug a number in and the equation is true, then that number is called the solution. The set of all the numbers that make an equation true is called the solution of an equation. So sometimes some equations, more complicated equations, you'll have more than one equation that can make the statement true. So, process of solving equations. when changing the form of an equation in an attempt to find a solution, anything you do to the equation should not affect what makes the equation true or false. So we can change things in mathematics, but we don't want to change the fundamental outcome. We change equations to make them easier, but we don't want to get a different number when we are done. We want to find a solution that works in the original equation. So that's the process of solving equations. Here's question 2. Okay. When you have answered question 2, restart the video. Question 2. The equation 5 equals 5 is obviously true, while the equation 5 equals 10 is obviously false. Multiply both sides of each equation by 2. What can you conclude? So, multiply by 2, multiply by 2, I get 10 equals 10. When we say 5 equals 10, which is a false statement, multiply both sides by 2. And as we've been doing, I'm using the parentheses. 10 equals 20. This is still true. This is still false. So multiplying both sides did not change whether it was true or false. So here's what you should have learned from question 2. Multiplying both sides of the equation doesn't change whether it's true or false. That's something we're going to find as we go through the lesson today. So restart the video once you've answered question 3, and we can discuss it. Question 3. We know that equation 1 foot equals 12 inches is a true statement. So it's also true that 3 feet equals 36 inches. Explain why. Well, and fundamentally in words, 3 feet, each one of those feet has 12 inches. If you have 3 12s, that makes 36. We could write that though. Although what they wanted you to do was actually explain it. We can multiply both sides by 3. And that gives us the true statement. But it's important to understand why it's true. Pause the video and come back when you have answered question 4. So on question 4, the equation 1 mile equals 5,280 feet is true, while the equation 1 yard equals 1 meter is false. Multiply both sides of each equation by 0. Explain why multiplying both sides of a conditional equation by 0 is a bad idea. So if I have 1 mile equals 5,280 feet, multiply by 0, multiply by 0, I get 0 miles equals 0 feet. That's still a true statement. But when I do 1 yard equals 1 meter, which is a false statement, multiply by 0, multiply by 0, I end up with 0 yards equals 0 meters, which is actually a true statement. So multiplying by 0, you lose part of the information that you had in the original equation. So when we talk about multiplying both sides by the same number, we don't really get any information from that if that number is 0. If we multiply both sides by 0, we basically lose any information that we would have had. Restart the video once you've answered question 5. So question 5, fill in the blank to complete a description of our first useful tool for solving equations. Then use it to solve the equation and check your answer. So we can multiply both sides of the equation by the same answer or expression, as long as that number or expression isn't equal to 0. So use your answer to solve the equation. I'm going to multiply both sides by 360. So I have 360 times d divided by 360. I can change the order. I can say d times 360 divided by 360. 360 divided by 360 is equal to 1. And then I have 0.35 times 360, which I'm going to do on my calculator. The 126. D equals 126. And now check to see if that's true. Well, that means we need to put 126 where D was. D was waiting for a number. That's a variable waiting for a number. Let's see if 126 is really that number. So 126 divided by 360. Yes, that gives us 0.35. Okay. Pause the video again and restart when you have answered question 6. All right, question 6. Is the solution you found in the color box the only solution to the equation? How can you tell? It really is the only solution. If I increase 126, I'm going to get a bigger answer than 0.35. If I decrease 126, I'm going to get a smaller answer. So the way this equation is set up, that because of the nature of this equation, that's the only solution. Uh, so did you get it? If you didn't get it, check your answer, of course, in the back of the lesson. Um, if you didn't get it and you can't figure out why, send me an email. So go on to question 7, pause the video, answer question 7, and come back when you're done. Question 7, we know that the equation 1 minute equals 60 seconds is true. We also know that half a minute equals 30 seconds is true. What did we do to both sides of the equation to produce an equivalent equation? So if I'm going to end up with 30 seconds and 1/2 a minute, then I would need to divide both of these by 2. And we notice that dividing them both by 2 also results in a true statement. So we started off with a true statement. We divided both sides by 2. We got another true statement. Restart the video after you've answered question 8. Question 8. Use the result of question 7 to fill in the blank, completing a description of our tool for solving equations. So we're developing some tools here. So the way they want us to say this, we can, what did we do to both sides? Divide both sides of the equation by the same number or expression, as long as that number or expression isn't equal to 0. That's important. Use your answer to the above. Use your answer above to solve the equation 5x equals 60. Intuitively, if we think about this, we can say, I'm going to multiply by 5. The answer is going to be 60. We can say we can find that x by taking 60 divided by 5. Division answers the question, what do I multiply by? The way we do that in algebra, we say we're going to divide this by 5 to get x. 5 divided by 5 is 1. 1 times x is x. So if we do that, we have to divide the 60 by 5 as well. We're dividing both sides by 5, and we get x equals 12. And just like before, we check it by putting it back in the original equation. Let's see what 5 times 12 is. We were hoping 5 times x would be 60. Is 12x? Well, is 5 times 12 60? Yes. So x must be 12. And you might have guessed we're going to kind of go on. We've decided we can multiply both sides of an equation. We can divide both sides of an equation. So we're going to work with that a little bit more. So talking really quickly about proportions before you get to question 9. When you have proportions where you have two fractions with an equal sign between them, which means that two actually they're ratios. In this case, they're ratios and fractions, but they're equal. There's an equal sign between them. A lot of times that's called, a solution to that is called cross multiplying. We have found that a lot of people use that term when they're multiplying fractions. 2/3 times 4/7. I would say I multiply the numerators and I multiply the denominators. Some people would say you multiply across, meaning the same thing. And a lot of people now are calling that cross multiplying. That's not what we're talking about here. This is what I'm used to calling cross multiplying. So cross multiplying, you would take the d times the 100 and you take the 360 times the 35. And a lot of people now are calling that the fish. So they, and they're, because I think they're doing that because they don't want people to confuse it with multiplying fractions. So they say we're going to multiply this and then we're going to multiply this, and it ends up looking like a fish. That's what's called cross multiplying. So when they talk about cross multiplying, that's what they mean. So question 9, restart the video once you've looked at question 9. All right, question 9. Use tool number 1 to multiply both sides of the original proportion by the number 100 times 360. So we're going to take our original proportion, and actually I'm going to do it in 2 steps. I think it's a little easier to see. D divided by 360 is 35 divided by 100. I'm going to multiply both sides by 360. And as we did before, the 360 divided by 360 gives you 1. You just end up with D. Now I'm going to multiply both sides by 100. And I didn't leave myself enough room. Hopefully you see I'm multiplying by 100 also. And now we have 100 times 100. If I do all of this, I can multiply 100 times 35 times 360 divided by 100. Or I can divide the hundreds right away. And I end up with 100D equals 35 times 360. So the fundamental idea of cross multiplication, or the fish, however you want to call it, the fundamental idea is that we're multiplying both sides by the same thing, and we end up without a denominator. But we're using the multiplication tools. So cross multiplication is really just problem solving. It's a trick that helps you remember what to do, but it doesn't help you understand it. So we're hopefully getting to some understanding. Actually, though, cross multiplication, you end up with 100 times D. When you cross multiply, you're supposed to say cross multiply and then divide. So divide by 100, divide by 100, and hopefully you see D equals whatever you get with that. Hopefully you see that with cross multiplication, I really didn't have to multiply both sides by 100 because I ended up dividing it and putting it back where it started. Okay. So do any obvious reducing of fractions. What do you notice about the final result? Final result is the same as what we got before. If you plug that into your calculator, you end up, actually, I believe you end up with 12, just like we did before. Okay. Go on to question 10. Restart the video once you've answered it. Okay. Question 10. Use cross multiplying to solve the proportion. Pretty straightforward. Over 12 equals 15 over 36. I'm going to go off on a tangent here really quickly. We've looked at this before. 15. We could actually take the 36 divided by 12, and then that tells us what to divide by 36. So actually we'll divide 36 by 3 to get 12. So we divide 15 by 3 to get 5. So divide by 3. That's really similar to reducing fractions, or finding a common denominator, using that same idea. Cross multiplication, like I said, it's like the fish. 36x equals 12 times 15. Divide both sides by 36. And then we end up with x equals 12 divided by 36, we can actually reduce that fraction. We can divide them both by 12. 1 over 3 times 5. That's basically the same as dividing 1 over 3 times 15. Basically the same thing as dividing 15 by 3. You get x equals 5. And if we go back, we to take a look at that equation to begin with. 5 divided by 12, is that equal to 15 divided by 36? Yes. We multiply this by 3, multiply this by 3, we would get 15 over 36. So cross multiplication does work. Uh, Hopefully you see that there's an idea behind it. Okay. Next thing I think we have is a did you get it? If you don't get it and you can't figure out why, um, you might send me an email. Okay. Go on to question 11. Restart the computer once you're done. Now let's work on building our next equation solving tool. We know that 1 minute equals 60 seconds. Is it okay to add the number 3 to both sides of the equation, resulting in 4 minutes equals 63 seconds? No, that's obviously not right. 4 minutes would actually equal, you would actually have 4 60s. So you'd have 4 times 60. So no. Restart the computer now restart the video when you have an answer to question 12. So is it okay to add 3 seconds to both sides of the equation, resulting in 1 minute and 3 seconds equals 63 seconds? Yes, that's correct. 1 minute and 1 minute and 3 seconds means 1 minute and 3 more seconds. And that is equal to 63 seconds because that 1 minute has 60 seconds in it. So they're really just trying to illustrate that we need to um, follow follow through with our units like we've done. We need to be consistent with our units. So restart the computer once you've done question 13. Use the result of question 12 to fill in the blank, completing a description of our next tool for solving equations. Then use it to solve the equation and check your answer. So we've noticed we can multiply both sides of an equation by the same thing. We can divide both sides of an equation by the same thing. And now we're understanding that we can add, and they say the same quantity or expression, to both sides of an equation. So use your answer to solve the equation. X minus 142 equals 70. Well, we know if we're going to find a number that we're going to subtract 142, the answer is going to be 70. We can find that number by adding 142 and 70. And that's actually what we're doing here. We're adding 142 to both sides of the equation. Okay. I'm running out of room. It's hard to write on this screen. So I want to make it look plus 142 plus 142. And we put a line under them because a lot of times when we add vertically, we put a horizontal line under it. So x minus 42 plus 42. If we subtract 42, we add 42, or 142 and negative 142 equals 0. X plus 0 just equals x. And 70 plus 142 is 212. So we have used our idea doing the same thing to both sides of the equation. we have x by itself, and it says literally x equals 212. Let's check to see if that's still true, or if that value is correct in the original equation. If I go back to my original equation, x is a variable waiting for a number. We now are proposing that 212 is that number. If we subtract 142 from 212, we get 70, and that is in fact true. Another did you get it? See if you can solve this equation. If you don't get it, send me an email. It is a little different. In fact, I'm going to, just to avoid an email, there are different ways to do this. It's different in that we now have 63 minus x instead of x minus a number. Two ways to do this. I'm going to show you both. So first idea I would use, I'm going to add x to both sides. A lot of people wouldn't do that. Now I'm going to subtract 230 from both sides. And 67. I believe so. Okay, so that's one option. You can add x to both sides. You don't have to worry about that negative. What you're typically taught to do in high school algebra is go in and, I don't know why I wrote 62, subtract that 63 from both sides. And when I subtract it, I end up with 167, but it equals negative x. Negative x, it's difficult sometimes for people to get their minds around it, but what we would do now is just multiply by -1. When you have two negatives, you multiply them together. It's like a negative times a negative is a positive. So we end up with positive x. And over here we have negative 167. So two ways you've probably seen to do that. You see you get the same answer each way. Try question 14. Restart the video once you're done. So given the fact that 36 inches equals 3 feet, subtract 5 inches from each side of the equation. Is the resulting still true? There's two ways you could have done that. I think they want you to do kind of the same thing they did when they were adding 3 seconds to both sides. So 36 inches plus 5, subtract 5 inches. Technically, you need to change the 3 feet to 2 feet and 12 inches. And then 12 inches minus 5 inches is 7 inches. And over here we have 31 inches. 2 feet is 24. 24 plus 7 is 31. So 2 feet 7 inches is equal to 31 inches. Alternatively, if you take 36 inches minus 5 equals 3 feet minus 5, and you say this is negative 2 feet equals 31 inches. That's obviously not true. I'm not sure which they were intending for you to do here. But either way, go on to question 15. And question 15 actually says fill in the blank. Once you've done that, restart the video and we will discuss it. So we can subtract the same quantity or expression from both sides of an equation. So use your answer above to solve the equation. N plus 1,361. You're making it hard for me. What we do is subtract 1,361 from both sides. And we draw a line underneath it to show that we are subtracting vertically. And 2,094 minus 1,361, 733. Check your answer. We are alleging that n, the variable waiting for a number, is the 733. So let's try it. The process that we went through is supposed to tell us whether this is true. I add those. 1,300 and 700 is 2,000. 33 and 61 is 94. So we have 2,094. So that is true. We were in fact able to subtract the same number from both sides of the equation and answer our question. And now we're kind of getting into kind of a summary here. So we kind of discussed that with you. So we've been solving in the types of equations we've been solving are called linear equations. If you'll notice, just like the linear equations we did in lesson 3-2, we only have x to the first power, and we don't even know that it's to the first power because we don't put a 1 there. But we don't have x to a second power or a third power. So that's kind of the idea. So summary of the steps for solving linear equations: simplify both sides of the equation, if necessary, by multiplying out any parentheses and combining any like terms. Step 2, use tools number 3 and or number 4 to rearrange the equation so that the term containing the variable is isolated on one side. So we add and subtract so that we just have the variable times a number or a divided by a number. That's what they mean by term. And we've talked about like terms. A term is a variable that's either multiplied or divided by a number. We have like terms like 3x plus 5x. The terms are 3x and 5x because they contain multiplication. Those two terms are kind of connected by the plus sign. So I have two distinct terms, and I can add them together to get 8x. But that's the idea behind a term. The term is the thing between the pluses and the minuses. Once we have just a term, one term with the variable, then we can either divide or multiply using tool number 1 or tool number 2 to get the variable by itself, or have a coefficient. Coefficient is the number next to the variable, the number multiplied by the variable, I should say. So this term has a coefficient of 3. This term has a coefficient of 5. And I make a quick note about fractions. Multiply by a common denominator. That gets rid of any fractions. I've seen people try to solve equations with fractions. You can do it. Get rid of the denominator. You don't have to worry about fractions. Okay. So do the did you get it number 4. See if you can get the right answer. If not, send me an email. Let's go on to the group work. We had this graph in the last equation, the snow cones. So using the graph was just fine, except that pesky estimate thing. We found that when we used the graph, we could get pretty close, but we weren't exactly at the number that would answer the question if we actually did the math. So what if we want exact answers instead? In that case, we need to have written an equation representing profit. If you think back to lesson 3-2, we did write an equation representing profit. And that has the y-intercept of negative 245, and it has the slope 0.163, which was the amount of money that we made on a snow cone. It's the unit rate for profit, the profit for one snow cone. And we found that slope and unit rates were really the same idea. So we're going to use that now to answer some questions about the problem using the algebra tools we just developed. So do question 1, and then come back and we will discuss it. Okay, question 1 in the group work. Given the fact that X represents the snow cones sold, what should we do to find the profit from selling 150 snow cones? So the equation we had was P equals negative 245 plus 0.63x. And x represents the number of snow cones. If we want to know how much we make for 105 snow cones, we are now told what x is. So the equation tells us multiply x times 0.63. We're going to multiply 150 times 0.63, add a negative 245, which was our cost. So, you can do that. I'll do it on the calculator. So, negative 245. Oops. And I did it wrong. To get negative on this calculator, I have to do 245 and then click on the plus or minus to change it to a negative. It was taking my last answer and subtracting 245 because I pushed the minus instead of the negative. Negative 245 plus 0.63 times 150. That gives me negative 150.5. Which you remember we calculated in the last lesson, although we didn't use the equation solving tools because we hadn't found them yet. We did check that on the graph and it compared pretty well to the graph. So in answer to question 2, it's the same thing we got. So try question 3, restart the video when you're done. Given that P represents profit, what should you do to find the number of snow cones needed to make a profit of $50? So I'll go back to our original equation. P equals negative 245 plus 0.63 times x. This is where things get interesting now. Now they're telling us P. So we actually have to put the $50 where P is. And the question is, how many snow cones do we need to sell? We're not being given X, we're asked to find X. So we leave that X in. And if you remember, we kind of did the same problem, I believe, in the last lesson. Now we have it in equation form. We can add 245 to both sides. And a lot of times you may have seen a lot of people like to cross that out to show that it goes away. Doesn't matter to me whether you do it or not, but it's important that you understand negative 245 plus 245 gives you 0. So now we have 295 from our plus 245 plus 50 equals, now we just have 0.63x, and we divide both sides by 0.63. And again, I'm going to go back to the calculator now. 295 divided by 0.63, 468 snow cones. And so I end up with x equals 468. 468 snow cones. Restart the video once you've looked at question 4. Okay, now you should be able to solve an equation to find the number of snow cones needed to make a profit of $50. If your solution requires rounding, think about what it would represent before deciding on a final answer. Okay. Actually, I think I just did that. Question 3, they just wanted you to put in the $50. Then why is this question in this lesson? Well, if you do that, you notice you have the x. So in question 4, you actually solve it. You'll notice my solution required rounding. Why did I say 468 snow cones instead of 468.3? That's really what they're asking about here. Well, obviously you can't sell 0.3 snow cones. Restart the video once you've looked at question 5. So on question 5, check your answer by plugging it back into the equation you wrote. So our answer now, we've come up with a value for x. We're saying that x equals 468 snow cones. So we can go back to our equation and put 468 where the x was. Because x was the variable waiting for a number. We now think we have that number. Let's put it there and see. So I'm going to go to my calculator. And the equation says take 0.63 times 468. Gives me 294 plus 245 negative. And you'll notice I did the multiplication before I added. and I get 49.84. So 468 doesn't give me exactly 50, but it gives me close to 50. Um, how many would I have to sell to get more than 50? Obviously, I'd have to go up to 469 to have more than 50. But I interpreted it to mean about 50. So anyway, restart the video once you've done question 6. Question 6, we're kind of just getting more practice. Use the equation to find the profit if 700 snow cones are sold. P equals negative 245 plus 0.63 times 700. Let's try it. 0.63 times 700. I do my multiplication before I do my addition. Now I add 245, but I make it negative, and I get $196 profit. Use the equation, question 7, to find the number of snow cones they'd need to sell to make a profit of $400. Restart the video once you've answered question 7. So we want our profit to be $400. I put that where the P is. And the question is, how many snow cones? We don't know what X is, so we leave it as X. That's the purpose of X. It's sitting there in place of a number we don't know. That's actually what we're trying to find. We're going to use our equation solving tools to find that. 245. If we think about the problem outside of solving equations, we want to answer this question. We know we're going to have to make a $400 profit. We're also going to have to make the $245 of fixed costs. So we have to make 245 to pay the fixed costs. We have to make another 400. We have to make a total of 645 dollars to get our 400 profit. And then if we want to see how we want to see how many snow cones we sell to get $645, we know we would have to divide 645 by 0.63. So in the context of the story, all of the things that we're doing really make sense. Which helps us understand the process of solving equations. So 1,024 snow cones in order to make $400 profit. Well, restart the video once you've looked at question 8. So question 8, look very carefully at the steps you did to solve the equations in question 4 and 7. Write those steps in words here. So they're really just trying to get you to verbalize what you've been doing. That really helps you remember it. So if you haven't done that, really, please do that before you hear what I have to say, because it's more important for you to say it than it is for you to hear it. But really, in question 4, we were given the number of snow cones. We just put that into the equation where the number of snow cones, the variable representing the number of snow cones was. Um, since that was all on all of the actual calculations were on that side of the equation, we had P equals negative 245 plus 0.63x. We just rewrote the equation with the number of snow cones in place of x, and then we did the calculations to find P. Question 7, uh, we were given the number of snow cones. Sorry, we were given the profit we were looking for. We had to find the number of snow cones. So in question 7, and I guess in question 4 as well, don't remember exactly what question 4 was, but we had to get the variable by itself. We had the profit. We have to add 245 to both sides, and then divide both sides by 0.63. So we used our equation solving tools to get the number of snow cones variable by itself. Question 9, restart the video once you've done that. So perform exactly the same steps you described in question 8 on this equation to solve for x. So they're really wanting us to take this a step further into a more abstract realm rather than just going through the procedures now. We haven't plugged anything in for P yet, but I can do the same thing. I can't actually add P and 245, but I can say P plus 245 equals 0.63x. So hopefully you'll see in a minute what we're getting at. Do the same thing, divide by 0.63. Divide this side by 0.63. And actually I have written an equation for the number of snow cones in terms of profit. If you remember what I was saying before, if we think about it, we want to know the profit, how many snow cones to make a profit. We need to take our profit plus our fixed costs. That's how much money we actually have to make. We need to divide that by the number of snow cones the amount of profit we make on each snow cone to tell us the number of snow cones. So really what they're wanting us to do here is rewrite the equation. Now we have instructions for calculating the number of snow cones when we know the number of the amount of profit. Go on to question 10. So question 10, what you just did was solve a literal equation. So we just rearranged the equation to find x in terms of p. This is another equation with more than one variable, so that when you solve for one of the variables, the result is an expression rather than a number. So we're not getting a number out here. We're just writing a new formula. When you're done with question 10, restart the video. Suppose we were interested in using this spreadsheet to calculate the number of snow cones um, that would be necessary to make a certain level of profit. What formula would you type into cell B2 to calculate the number of snow cones needed to break even? I'm not expecting you to understand how to write the Excel formula, but you really want to just use that formula we just looked at. You want to put this formula into that cell. So I'm not going to write it in here because I don't have room. We would write equals. We want this cell to equal P, which is A2 plus 245, and Excel doesn't have two different lines. You have to write it all on the same line, divided by 0.63. And that kind of illustrates one of the main benefits of using literal equations. When I'm taught programming classes, we have to do this because um, when you're using the computer, you need to write an equation that the computer can use. Um, and you end up having to solve for a different equation rather than solving for an actual number. Computers applications are one of the main places where we use that. So, question 11, use a calculator or a spreadsheet to complete the table. Then describe why solving the equation for x was helpful. Restart the video once you've done that. Particularly explain or describe why it was helpful. Hopefully you noticed when you did this that having the equation written in terms of p, where you calculate x using p, you don't have to solve each equation. You just plug the numbers in. That's one of the reasons that using the literal equations is very helpful. Try question 12 and come back when you are done with that. So we got two equations here for calculating temperature. Fahrenheit temperature if you know Celsius, and Celsius temperature if you know Fahrenheit. You really don't need both equations. One equation will get you the answer. You just may have to solve it. So let's start with the formula that calculates F in terms of C. So if you know C, you use this equation to find F. We want to solve that for C. So first thing we do is subtract 32 from both sides. Now, once you do question 13, restart the video. We will discuss it. So question 13, now multiply both sides by, they leave the question blank, or you have to fill in the blank, which is the reciprocal of the fraction in the equation. I would actually multiply both sides by 5 and then divide both sides by 9. But they want you to multiply both sides by 5/9, which is fine. You're basically doing the same thing I would do. You're just doing it all at once. And that's okay. Saving time is not a bad thing. F minus 32 equals, I'll go ahead and write in the 9/5 C and multiply it by 5/9. So we have 5 divided by 5, which is 1, 9 divided by 9, which is 1, We're just left with C. And that's actually where this equation comes from, which is actually the answer to question 14. I shouldn't have given away the answer, but that's the whole idea, that we used one equation to get the other equation. So solving literal equations, pretend that all the variables other than one you're solving for are just numbers, not letters. So we do the same steps that we would do if we knew the variables. Use normal equation solving procedures to solve for the desired variable. We just don't end up with a number as the answer. So they've given us an equation, A equals P plus PRT, and you might remember that as account equals the principal plus the principal times the rate times the time. Solve that for T, solve that for the time. See if you got it. If you didn't get it, send me an email. We will discuss it. Okay. We're just about done here. On to the portfolio. As usual, we don't do the technology. The online practice is the ALEX. You need to do your ALEX. The last thing you need to do is the applications. And I will have a place on D2L where you can upload those applications. Thanks for watching, and I will see you for lesson 3-4.